So I had a stream earlier about doing my little audio driver coding library, and it was a lot of fun. So I thought I would continue it. Let's see if I have everything set up correctly. So let me kind of rephrase a little bit of what I'm doing here. So what I'm doing is I'm writing this audio driver library that's going to be free and open source. The idea is to write something that would be very easy to use, self-contained C++ library. I'm going to start by doing this as a wrapper around RT audio. In the future, there might be more backends like Juice or maybe native libraries and stuff like that. And the idea is to make something that's very easy to use from an existing C++ code base. So the idea is something that has very minimal setup, unless you write some minimal setup code, work, but also connect with your UI or whatever logic that you're doing. It should be something that's almost trivial. So if you can see right now, let me show my screen. So on the screen here, maybe I can do this, or maybe this. This is nicer. Okay, so what you see is I have some code on screen, and this is basically the entire code, this page, to bring up this library and run an audio callback. This actually includes this part. It's like a function that makes white noise in this case. But really the use of the library is just these. I don't even need this line. This was just something for testing. So it's just these two lines, right? In 2 lines, you run a device manager, you connect to the default config, and it plays. I'm just going to play it, and hopefully you will hear some nice white noise. This actually plays through my speakers right now, and yeah, so this is something that can do stuff like query the devices that you have on your computer, like the audio devices, internal audio devices, external ones, give you information about them, and either connect to the default or give you more advanced configuration options. So what I'm doing here is as an iterative stream is that I'm trying to make it better, make it have better API and better implementations and all that. So yeah, so this is basically it. And let's get going here. So what I'm going to do today, or the stream, because I was already streaming a couple of hours ago, is that I want to I realize there's a few things missing from this callback. So let's dive into it. So this is the audio callback, which is like something supplied by the user, not by the library. What I did supply, I had some wrappers to give you like a nice structure that has everything that you need in terms of like buffers and stuff that the program is going to play audio through. But there's a few things that I didn't like about it, and I wanted to improve them. So let's have a look at exactly what this thing looks like. So as you can see, I'm passing a function. It's called audio callback info. And what it has is it's got a few data members, and the audio buffers are actually coming in as void pointers. That's actually how they're given from the device driver, from the underlying system property. And what I do is I actually cast them into more concrete buffers. So I cast them, for example, into floats in this case. Or first of all, this probably should not be a float, right? Because I did a template type named T, but I kind of ignored the T. So it actually should be like this, T star. So it should be returning whatever you get into it. So if you had a 64-bit audio processing, you should be able to ask for a double. So that's better. So now on my user code or my little testing app, I can come here. I don't know if this is, let's go back to a full screen coding mode. Might be better. Let's do this. Here you go. Okay. Or let's bring myself up just in a little box in the corner. Good. So the idea is, and maybe I'll make the font even bigger. Hopefully this is clear, but maybe I'll need a little bit more size here. Let's do something like 20. Yeah, hopefully this is more clear. Yeah, so by the way, I'm here answering also questions in the comments. So if you have questions about what I'm doing, why I'm doing it, I'm happy to go back and explain things. This is meant to be also, I guess, educational of sorts. So it would be great if you wanna let me know. I'm streaming this on a number of different networks. So this happens on Twitch, YouTube, Facebook, Twitter, maybe something else. I think that's it. So you can leave me comments. I'll try to put them on screen as well, so other people from the other medias can see them, and we can hopefully have a productive time together. So, right. So what happens with this thing is, as you can see, when inside of the audio callback, when I'm making sounds, is where I do something like get outputs. Wait, I need to hear music on my headphones. It's getting a bit loud. Okay. So the idea is that you can cast the output buffer. The buffer is, just to be clear, the buffer is really where the sound is played. So when you think about the actual audio, an actual audio application for people who haven't programmed audio before, an audio application basically gets some sort of like an array of samples from the sound card or from the DAW or something like that. And the job of the audio app is to fill them, right? Yeah, so there's a question, interesting question here. So, okay, so Abhishek asks, hey Eyal, what's the end goal of this library? Cross-platform? What's a potential use case? Okay, this is a great question. So first of all, yes, this is meant to be cross-platform. Right now, this is wrapping a backend called RT Audio. So that means this is going to work for Mac, Windows, and Linux. In the future, I might make another backend that will work with something like iOS and Android, other platforms. But this would be the start. And yeah, so the use case is for any kind of audio apps, like you make a DAW, you make some standalone synthesizer, or you make some even just a testing app to test your DSP library, or you make a recording software, looper, anything like that. It's meant to be a super easy way for you to get up to speed and actually get sound. So the library I'm wrapping, for example, that's called RT Audio, is, in my opinion, very difficult to use. Like I have, just the implementation of getting a sound together required, quite a lot of, I had like 200 lines here, 200 lines there. Like I had like 600 lines of code just to get some audio to sound. I thought it was annoying. I wanted to make sure that your C++ code, if you just want to make sound, you can make a console app, 2 lines of code, and get sounds and get callbacks. There will be more APIs later for stuff like UI, which is also very annoying and very difficult to connect to if you're just wrapping the library. I also wanted to connect to do stuff like thread management when you do all these changes of the audio devices from the app. So this is really the use case. It's meant to be a free and open source library. Like this is not something proprietary I'm writing for my plugin company, Modalix, or anything like that. This is very much a low level thing that's just meant to be, as simple as a C++ library could be to use, and to, answer all the requirements of something like this, right? Help you get everything you need. So hopefully that answered the question. I'm happy to answer more questions, by the way, just before I get ultra technical, and I will get ultra technical along as the stream is happening. Okay. So what I was going to say is that this library wraps. So just to give you an idea, there was this line that I deleted earlier, right? Just to go back to what the previous stream did. So I'm just going to have a breakpoint here. And you see what this thing did? I did O2 info equals to manager get devices. And what that gave me is it gave me a nice detailed list, right, of everything, of all the devices I have on my computer. And you'll see there's quite a lot, right? For example, the first device is going to be the it's my external display microphone, right? That's one device. It has one input, but no outputs. The next one is going to be the same thing, but the speakers. That thing has 8 outputs. I have no idea how they have 8 outputs on the studio display speakers, but maybe there is some surround happening there. I didn't check. That's cool. The next thing has, the internal MacBook microphone, right? So there's a bunch of devices happening here. You can also see that they support things. Like, for example, they support different sample rates. Like, these are the sample rates that get supported. 44,100, 48,000, 88,200, 96,000. There's also types, which we'll talk about this later. There's a few ways to pass the pass audio buffers. The most standard one usually is float 32, but there's also 64-bit float. That's a more, higher precision way to process. So you'll see that I get all these devices and they provide a lot of different things. Like, let's see if I get my more professional devices here. So let's go to the end. And you see this gave me my RME Firefrace UFX. That's what I'm using to stream right now. And that thing has 30 outputs, 30 inputs. That's kind of cool. It's the default, right? It's got 9 sample rates. Look at this. This thing supports 192,000 or 192 kilohertz, 176.4 kilohertz, right? Way more options. It still does only 32-bit floats though. So these are like the general cases of such library. Like, you want somewhere to communicate with the system using, from the different OSs. And you want a nice way so that your higher level app, UI, configuration area, whatever, can communicate with this data. And the low level library I'm using, RT Audio, that's going to be what I'm mostly working with now. It's a library that already implemented all of this. I just didn't love the interface. I thought a lot can be done in the API of the scope. Right. So, I'll get some water. As I said again, feel free to leave a comment. I'm broadcasting this on a number of different networks, YouTube, Facebook, Twitch, but I'm seeing all LinkedIn as well. I'm seeing all the combined comments from everybody, and I'll try to answer as we go along. Okay, so back to what we're doing. So what I did was I realized that this data kind of comes in, and it comes in from the driver or from this, I guess, this underlying library as a void pointer. Like, this could be a bunch of different types. And then what I do is I turn it into an array, like a float array or a float pointer that behaves similar to an array, only on use. So what happens is when you're in your audio code, and you have a for loop over all the different outputs, and then you do something like info get outputs. In this case, this audio just does output. There's no input handling. You ask for it to be converted into a float. And that works. That's also going to work with an int. It's also going to work with a double. Or in 8 bits and 16 bits, all that, it should work. What's not going to work, in my opinion, it's not going to work well when the data is interleaved. So I thought that, most device drivers give you the audio as a big array of samples for the left channel. Then they give you a big array of samples for the right channel, and so on and so forth for something like surround sound, or for something like a multi-track recording device. But some devices, not mine apparently, but some devices do give you the data as interleaved audio. And interleaved audio means that you're going to get the audio as like one sample on the left channel, one sample on the right channel, one sample on the left. So they kind of bounce between them. So you can't really treat this as an array. In this case, there's actually a few different solutions offered to this. So something like a chalk. Chalk is an audio library. A chalk buffer can handle all these different types. What I will do for now, just because I don't want to make this too complicated, I just wanted to give an option to get this. And technically, yeah, because if you have interleaved audio, you can't really do this. In my default settings, I did not allow any kind of interleaved, but you can allow it with the settings. So the only thing I was missing here is I wanted to allow something like it's the same thing, but I'm going to call this get interleaved input, and this would just return a cast into the type you've asked for of the input. And I'm going to do the same with the output. And this is actually not an input. This is actually the inputs and outputs, right? Because they're all going to be interleaved into the same buffer. So this is going to be the output buffer. So this was just the first thing that I noticed when I did this. There's something else I noticed when I did this. This is a bit more heavyweight operation. So if any one of the viewers here ever used something like Juice, usually in Juice you get not just a process call, but you also get a prepare call. Just notice that I didn't show what I was just doing. So let's go back to the code. So there's in something like Juice, you don't just get this. This would be similar to something like a Juice process block, right? If you've used a Juice plugin or something, use process block. But this is usually not good enough. In Juice, usually they give you a prepare call, and a prepare call is your chance when something changes to do stuff like allocate memory and do everything that basically the process block will need to do, because the process block is not allowed to allocate memory if you're doing a real-time app. If you'll allocate memory here, like if you'll do something like I don't know, a std vector of int x, and then you'll do x resize 500, this is going to allocate a bunch of memory, and this will create quite a few problems, because the way audio works, your audio your audio device calls your program and says, give me audio. And if you don't give it audio in time, the device will still try to play it back through the speakers. And that's going to sound very unpleasant. If you've ever, tried to load too many plugins, in your DAW, you know what that sounds like. Like you hear cracks, pops, and unpleasant things. So usually you don't want to do something like allocate memory here, because allocating would create potentially a call to the system, which would wait too long until you would be, or you'll wait too long and you won't be able to return the audio to the interface. There's another question here from Abhishek. I hope I'm saying the name correctly. Do you think it's worth writing something like this to replace the Juice audio processing system, or is this far more robust than we know? I don't know if it's more robust. I didn't test yet, and by the way, this is more like, for now at least, this is more like, let's call it a front end for other libraries. So I will actually use one of the backends that a user can choose from will probably be something like the Juice Audio Device Manager. But if you're already using Juice, Juice solves this problem, right? Some will ask if some will argue that, if Juice solves this, why even write something else? The need to write something else is because there's some cases where you just can't use Juice. Juice has a commercial license. It might not work for your use case and stuff like that. And Juice is also quite heavyweight. Like, it requires you to build with the Juice build system and stuff like that. Juice is not so easy to build as a static library, for example. So there's a lot of different reasons, technical reasons or licensing reasons why you might want to use something else and not Juice. We use Juice in our in Modalix in our company, but it just doesn't work with every use case, and it's much nicer to just be able to bring up a console app and import a header, for example, which is what this library will eventually be, and just get going with sound, like instead of Juice, where you sometimes have to kind of buy into the Juice system to do certain things. Another question here. Zohaib Hassan asks, are you an audio engineer? I used to be an audio engineer for many years. This used to be my job. I used to be a mixer and producer and a musician and somebody who plays keyboards and writes music and stuff like that. And in the last few years, I've been doing mostly audio programming. Like I've been writing plugins and audio apps and stuff like that, mostly in C++, but a little bit in other languages. And I have a plugins company called Modalix, which you should check out. It's modalix.com. We make really cool plugins. At some point, I will do demos for my stuff, which my channels everywhere is full of them. So I don't want to spam this more technical stream, but it's there if you want to search for it. Okay. So back to what I was saying. So what I said was this is something like the Juice process block. Even though it's not using Juice, it's using. You see, this is my entire main function. By the way, let me stop this breakpoint. I can just remove this. It's just 2 lines, right? Everything else is just like user code. It's what my program does. But the way you use this library is just a couple of lines, and you can make sound and play stuff. Like I'm just going to play this, and this sounds like the like white noise, and I'm playing through it. Abhishek has another question. Let's see what it is. We have an audio engine that we've developed. I'm a long-time Juice user, but we don't want our customers to have to buy a license to it if they're using the device manager. For those customers alone, I think it makes sense to roll your own implementation. Exactly. And by the way, what I'm doing now, there's more here. Can I scroll and show the rest? I don't know. But the rest is something like, I think it makes sense to roll your own implementation. So thanks for doing this live stream. Very informative. So this library is meant to be free and open source. There's not going to be any license on this. It's going to be very, straightforward to use, and not. I'll make this public probably after a couple of streams where I continue to develop this. And so it's meant to be something lightweight that you bring in just for this. This is not going to be an audio framework. It's not going to do plugin wrappers. There's not going to be any threading, cross-platform message thread in this. It's just going to be the audio driver. So it's going to be easy to kind of patch to and from other libraries and other use cases. Juice, Juice is amazing. It's an amazing piece of work. It's just like you kind of have to buy into Juice if you're using Juice. So it's something else. Okay, so what I was saying is that now that we got this, and I started to explain that this is like the process block. We don't want to do stuff like allocate memory here. These calls will allocate memory. And we don't want to do this because this might cause cracks and pops and unpredictable things. But we do need to allocate some memory. We do need that whenever something like the sample rate changes, we do allocate memory, because something like if we have a synthesizer, it would have oscillators or effects in it. All of those would need to kind of be prepared for this new sample rate, the new buffer size. So usually what we do is we do allocate memory only once, and then we would stop allocating memory for the rest of the playback. So that for example, if you're the user and you change the sample rate, you would see the engine kind of spike for a second because it does kind of prepare itself, and then it's operating smoothly since then. That's how it usually works in audio applications. So So what I want to do, I want to have some callback that the user will be able to call to kind of allocate their own memory, because the user is going to determine which memory it is. So one way the user can, of course, do something probably like, this info thing. It gives you, I see, it doesn't give you the sample rate, right? So first of all, why don't I give the user the sample rate? That will be nice. So let's pass some information in here the user could be prepared for. So how do I do that? I am going to look at my implementation here. These are all my types. These are probably more interesting. Let's see. These are, here you go. So the user is going to do something like start. And when I do start, I open the stream with this config thing. And I'm saving the config. The config does have, when I do the config, when I open this, yeah, so this is where I pass stuff like the sample rate that the user decided. Maybe they set it up on their UI or something like that. What I want to do is I want to kind of save, at least some of this information, and I want to give it to the user when they're processing, right? And since this is kind of a heavyweight object, this might have vectors of things, I believe, right? It has like some stream options. It could have a string in it. So I don't want to pass it by copy to the user, but I could give it to the user by reference or pointer or something, so that it will be easy for them to always access this. So what I do is I have this object called callback, which this is the object that I'm calling to give the user the chance to process their audio. So, and this object is basically where I can give them anything I want for them to know the configuration and stuff like that. Great. So what I'm going to do is I'm going to also put in here something like I think it's called config, right? How do I call this thing? Or maybe it's on the bottom here. Yeah, this thing, the config. Yeah, so let's put this above this thing. Oh, there's a couple of methods there that I might need to move up as well. Good. So what I will do is I will also give the audio callback info something like a const pointer or something to the config. Yeah. So I think the reason I will do this with is wait, if I do something like config. I never forget these rules in C++. Yeah, so I think it's not const pointer. I'm confused. It's a pointer to a const, because I don't want them to, right? Is this correct? Right? Config. Right, I can change this. Yeah. No? Oh. Change this here. No, it is a const pointer. I'm just out of it. Keep forgetting basic C++ stuff. Right? If I do this here. Yeah, good. Okay, so I have a const pointer. The reason why I'm doing this as a const pointer is I don't want the user to let me think about this. Yeah, because I don't want the user to change this in their process block. That's not going to help anybody. So I just want them to have a view over this. Now, when I create this in my in the part where I open the stream, it's going to be called something like open stream. Yeah. So when I have this thing called, where are you? Open stream. Oh, and the callback. Here you go. So here, when I create the callback, I'm going to save the config here. I think it should work, right? Oh. Why not? Not audio callback info. I'm out of it. This should be stream config. Yes, good. So the reason why I did this is I want to help. I want to help the users here. Now the user can do something like info.config sample rate. Like the user can access this, and they can also do something like compare. Hey, is the sample rate different from what it was before? So let's say the user somehow stored the previous sample rate. They could do something like, well, if info config.sample rate or arrow sample rate isn't the previous sample rate, then let's store the current sample rate and then do some memory allocation. So I can do something like std cout sr changed. Let's allocate memory. And let's see if this actually worked. I can remove this, and then I'm going to do my audio processing. So to check that it works, what I'm going to do is I'm going to do something that might break. I've not tested it. I want to change the config. So right now I've only used the default config. And what I will do now is I will change the config after a little while. So I will do something like I'm going to store this config. I'm going to set the default config. And then, you know what? I didn't even have an option. I don't even have an option to set the config. So let's see if I can do that. Let's have something like void set config. It's going to take a new config. I'm going to do something pretty not thread safe now. So let's ignore the fact that what I'm doing is really bad. I will write the proper implementation of this in a second. So let's do. I can. You know what? I can just call this. Yeah, something like that. I can do that. Let's imagine that set config is also going to start. So first of all, it's going to stop, which I probably should be doing it here as well. Yeah. So, and then I will call this from this. So set config. I have not tested if this actually works, like changing this in runtime, but I would try it and see if I would try to, you know what, there's actually a better way. Before I test this, which I probably need to, I am going to let this run with the default config, and I'm going to change the, oh, I just realized I probably don't need to do that. If I'll change the sample rate on my audio interface, which is what I thought I would do, this might break the stream. I didn't think about that. Let me think about this problem for a second. See, that's the interesting part about doing something I've never done before. I need to think about these crazy problems. Yeah, so I think what I'll do is I'll actually use another interface from what I'm streaming with. So let's see if this is going to work. Yeah, and I will try to use the set config thing. We'll see if that works. So I'm not going to use the default config because the default config might be problematic. I'm going to write my own function to create a config, and I will create two manual configurations for the same interface, but with different let's say sample rate, and I will see what the driver is going to do about this. Will I be able to use the same one? Probably not, right? No. Okay. So I'm just going to copy the library function that get default config. This is a make a sound, and what this gets is a make a sound device manager. Make a sound. Okay, so yeah, so what I'm going to do is I'm going to first go to the manager and ask for the list of devices. Get devices. And I'm just going to ignore input. I don't think I need an input for this. I just need something like set, I think the first one, no, the second one was my my speakers. So what I'm going to do is I'm going to use I'm just going to hard code things just to make this simpler. I'm going to use the devices one, like the second one. This is just a hard coded way to do this. Is it input false? Okay. And now let's set a sampler. Now I want to set two different sample rates. So first of all, I want to start with, let's say int sample rate, SR. Okay. Get config. So I'm going to create one config, and then I'm going to create another config. This is going to be the flow that I'm working with. So I get the config. So I don't need the default config anymore. First of all, I'll just start to use this config, get config, manager 44100. Okay, I'm going to do this and see if this is going to work and my speakers are not blowing up. Hope for the best. Okay, let's see if it's possible. I don't hear anything, but it's possible that my audio is okay. Hopefully you can still hear me and I did not get disconnected. Please let me know if I'm still around. I don't know if you could hear this, but it worked. It did play sound through my speakers, and it gave me this SR change on the very first time that the sample rate was changed. Now what I'm going to do, in hopes that my computer will not break, is get two different configs. So I want to start this with this. Yeah, I can probably just start it again. Let's see if I can just start it again, but with a 48 config. But I don't know if I want to do it right after the other, because the call to this might take a little while until the actual thread starts. So I'll give it some hold. So I'll do something like, let's do something like wait for 3 seconds, then switch. So start at 48, then switch, go to 44, then wait for 3 seconds again, and finish. So let's see what this does. Hear sound. Okay, stopped. Here you go, perfect. So what happened, I don't know if you could hear my audio because I wasn't streaming it through my regular card, but I was hearing the sound, then the sound stopped. Probably when I called this made the sound stop. Then my my audio processor here, right here, you see, had different sample rates, so it knew to call this memory allocation function, and that's really helpful. However, that was pretty manual. We will also see there are probably other situations where the sample rate changes. Like I think it's possible, for example, the computer itself would change the sample rate. So I probably need to do some more heavyweight work on this. The first thing I probably need to do, which I need to figure out what happens, is I need to know what happens when this library, RT Audio, when it changes the sample rate for me. That's also possible. Like it's not necessarily guaranteed that if the user, if you went to an audio application and the user set 44100 or 44.1 K samples sample rate, there's no guarantees that the audio device won't change. So I need some way to know what the real sample rate is. And let's see if I can know that. Let's see if there's a way for me to query that or to find it out. I'm not sure. Let's see. So what I probably need to do is is in this RT audio file. There should be something like sample rate. Let's search for that. Okay, get stream sample rate. That's interesting. Okay, so I guess this is pretty much what I need, right? This says that, just like I said, that returns actual sample rate used by the open stream. So that's pretty much the data that I need. And same thing, I think this is probably something that I need. What's this? Latency. That's interesting. Transfer latency in sample frames. Let's see, trend late audio. Offering audio system hardware. Will replace some of. Okay. So I have a call from Yellow Baker. This is, which IDE is this? This is Sea Lion. It's not the default theme. It's a theme called Atom Heart Dark. It's a plugin for the theme, but this is just plain old Sea Lion, which is my favorite IDE. Okay. Yele, by the way, is also an excellent audio programmer who does amazing things in the scene. So let's see. So I'm reading a bit more about the interface of this. So one thing I saw here is that I can actually query the stream for the actual sample rate, right? This probably will be useful. And I also got the latency. I wonder if the latency I'm not sure what the latency is. Is this the buffer size? I don't know. That's interesting. Do I have a way to get the real buffer size? Or maybe buffer size means latency. Or maybe latency means buffer size, right? It's possible. Let's have a look. Let's see what kind of numbers I'm getting here. Let's query this. So what I'm going to do is in the library itself and make a sound. I have this little callback here. So this is the actual callback, right? This is quite dirty. I've explained this in the previous stream, but to kind of recap that, this is a callback that you pass into the this library, RT Audio, and that callback, because that callback is a very low-level C callback, it does not allow you to do a lambda capture. So I'm not allowed to capture my class device manager. I'm not able to capture it in the call. Instead, I had to pass it as a void pointer user data when I initiated this callback, and then when it calls me back with this void pointer, I need to cast it to the type that I know it is, which is device manager. So this is kind of like a hacky way to pass a lambda into a C library. It's kind of annoying, but it's what I could do. Yeah. So what I did was I then called this function that creates an object. But I think I need to pass more things into this. But first of all, let's see if I know what I'm pretty sure I will get the sample rate here. So first of all, I might save it right here. I might do something like, unsigned int sample rate. And I really want to know the block size as well. Or I don't know if I want to know the block size. I need to know the maximum block size. Because this thing, n frames, which I probably should change. This is some name I stole from RT Audio. Let's change it to num samples or something. I like that better. Yeah, this is better. So this thing is going to give me the current number of samples in the buffer. But it's possible that the driver would give me the maximum block size in chunks. Like it's possible that if the block size is 128, I will be called with 2 calls of 64 or some division of that. But the maximum is important because this is going to be related to the amount of memory that I need to allocate. Like I need to know in advance when the user sets up something like 512 in their DAW. This could be used in a DAW. as the audio app, I need to know that maximum number, because then I need to allocate all kinds of arrays and buffers and pointers to match up with this this block size. So these two are important. Like I need to know what they are. And I also probably need to know if number of inputs or outputs changed. Maybe I need to know if the device is different. I don't know. We'll have to see exactly what do I need to know about this. Okay. So what I do is, this function is becoming pretty massive, but I'm going to add more stuff in it just for fun anyway. So I'm going to do something like unsigned int sample rate. And I'm going to call this max block size, but I'm actually not sure. I'm not 100% sure that these are actually the right things given by the library. I'm going to need to debug this and see. So info dot sample rate equals sample rate, info dot max block size equals block size. Max block size. Okay. By the way, just for people who are joining, I'm writing a library that does audio drivers. It wraps, and for now, it wraps in another library called RT Audio and helps do cross-platform drivers. Feel free to ask me any questions. I'm going to be answering questions during this whole stream. And let's continue. So, okay, so I'm going to, I need to pass the, I'll do something like out SR equals manager. Oh, I did not expose the sample rate. So let's start exposing these in the manager. I don't love the idea that I'm going to expose this in here, but maybe. Okay, I'll expose this here for now. I don't love it, but we'll see. Maybe what I'm doing is too ugly. Okay, I'll start with this, and then what am I calling this? Here we go. So to SR equals manager dot to block equals manager. Block. Okay. I'm kind of hoping polling on this makes sense. I kind of need to check, but hopefully this just reads from some reads from some predetermined array, and it's not actually going to the interface or something at this point. Let's have a look what this does. And while I'm here, let's go to my let's call it my user code of sorts, and I also want to print what is the block size. So let's do something like std cout block size. Okay, let's have a look. So this example that I'm running is, okay, 1056. So there's no doubt that this is not the block size. This is just some latency thing that is not the block size. So I need some way to find out what the real block size is. This is going to be interesting because I did pass it, and I think it is calling me. Let's have a look. I think it is going to call me with the right number of samples, right? Yeah, it did call me with number of samples, 512, which is what I asked for. Like when I created the config, right here, right? I created a config with 512. So it did give me what I asked in terms of what's in the buffer. Maybe there's no way to actually query the block size beyond that. Let's read more in RT Audio and see if there's how did they call block size? I forget. There's a name for this. It's not buffer frames. It's All right, they call it something like end frames. But how did I ask for this? I used some name. Buffer frames. Okay, let's see exactly where did they. Oh, here it is. Pointer value indicating the desired buffer size and sample frames. The actual values is returned by the same pointer. Okay. Okay, I see what happens here. Yes, I think I did handle that. I actually forgot that I handled this already. But this is kind of strange because here, so when I open the stream, this is where most of the setup in this library happens, open stream. I do remember that open stream. Yeah, I did give it out of frames equals buffer. Okay, yeah, I think that's what happened. I think what happened was frames. Okay, I think I am getting, yeah, this thing, frames. So I am getting it when I open the stream. That's actually true. So I think what I should do is, I think I'm asking for a stream, and then the open stream method gives me back how many, what's the actual block size. So I think I need to store this somewhere, right? I think what I'll do is instead of, yeah. Okay, so I think it is buffer frames. So I think, but what I should do is probably do something like this. So I should take it by reference and store it in the actual thing. Yeah, I think that would be correct. And this is going to store it in the config. So that makes sense. I can just go to when to make this convenient, I can, yeah, I don't need to take the latency. I don't know what this latency thing is, but maybe I'll store it just for fun, even though I have no idea what it is. I'll store it here so that I will have it for whatever reference that I need. So let's edit this something for the struct for latency. So this is actually going to be latency. The maximum block size, I do need to somehow pass in here. Oh, but I do actually have it because I have the config. So I can just do something like, which I think this is okay-ish, but at config dot buffer frames. Let's change this to max block size. This would make more sense. So this is theoretically true, like this, or technically correct, but I don't know, something weirds me out about it because I know that this number can actually change not by the user, right? Like I know that we can run the DAW or something, and then some other program is going to change the sample rate, and I'm not sure all the kind of audio driver backends allow you to do that, because I'm not going to get any call from this. So I need some way to know that, I mean, I could know that n frames is different. Maybe this is what I can do. Maybe what I'll do is, yeah, because I can kind of assuming, okay, so there's a question here from Noam. What are we programming today? So what I'm programming is a cross-platform library for drivers. So to give you an idea, there's still a bunch of code here, but the idea is to do something that with a couple of lines, like you don't even need these three lines. The 3 lines is just for my testing. With these 2 lines, you should be able to open a driver, an audio driver on Mac, Windows, and Linux, and start making sound. Like it's a very, very quick and easy way that, in theory, should even be used by professional software and stuff like that. To just open the drivers, connect to all kinds of drivers if you have multiple devices, change the sample rate, change the buffer size, stuff like that. So it's stuff for real-time audio, and I am building this on top for now, on top of a library called RT Audio. So I'm building like let's call it an interface for that library, and in the future for other backends. Okay, hopefully that answered the question. Okay. Where are we? So the thing I was trying to figure out, this is not block, by the way. This is now latency. This is just lying. I need my variable names to say what they mean. The one thing I still didn't figure out, maybe I can hold this for later, but I still didn't figure out how do you handle something like the buffer size changing not by the user, changing by some other program on the computer. I'm guessing, and I can't really test this right now because I'm streaming. I'm guessing without, and my guess is probably not good, so I will need to run proper testing when I'm not streaming from the same interface that I'm listening to. I'm guessing that if this is different, like what the device is calling me in the callback, like if the sound card tells me, hey, up until now we were in 4400, or sorry, not 4400, in a buffer size of 128. Now we're in a buffer size of 64. Well, I probably can look at it and say, oh, this is probably different. This is probably means that the current block size is different. So for now, I don't know if what I'm doing is super true, but I would try to just use whatever I get in the buffer as the truth, and I will look later and see if that actually is what happens. So I will do something like I'm gonna assume that the block size is not the config max block size, but it's actually same as what's it called, end frames. I hate it called end frames. Let's call this num samples. Here you go. I'll kind of assume this is the same as before. I'm not sure this is this is actually like the actual num samples and the maximum are the same value. It's probably not true, but I don't know. I need to run more tests to see how exactly this works. Now, what I want to do at the end is for the user code. This is the user code. This is some function that the user of this library, the imaginary user, wrote. And yeah, this is unsigned int. And I want to do something that will help the user get a prepare call whenever something changes. And the user could, in theory, do something like this. If the sample rate is not the same, do this. If the buffer size not the same, do this. Like kind of run through a lot. And I don't know if I want to do that. I think what I would rather do is yeah, so I think what I'm going to do is oh, but there's a very interesting comment here from Exa Acoustics on Twitter. Oh, what is this? Ooh, okay. So if I recall correctly, RT Audio lacked callbacks that detect new removed audio drivers. I created my own for the C-Plug standalone builds. Take a look later if that is. Yes, this is very interesting, and I will take a look. And by the way, that's something kind of important. There's a lot that in terms of like what the user needs that I'm actually adding on top of RT Audio. So, for example, something like a callback, right? We're just talking about a callback for a change. There's no such callbacks in my, as far as I know, from RT Audio itself. But like, there's no callbacks in RT Audio itself. But I can generate the callback. Like, I can do, like some low level. I can do like some polling once in a while, and create a new callback. There's also an interesting question about do you like if because you really want to have this kind of callback from something like the UI, right? Because the UI needs to know if the device got disconnected. What you would need to know in the audio process side is if the device that's selected is disconnected. Like, you need to know if the device, I think that you will get an error. There is an error code in RT Audio for that. I didn't check yet about all the different, like, is it actually transmitting correct error codes and stuff like that. Yeah, I think it's possible. I think like in what I would need to know, and I did add a little bit of that, but there's going to need to be added more error handling. Like, hey, you had this thing, the audio stopped working, so there should be something like a callback to you saying, hey, do you want to switch back to the default, or do you want to open something for the user? Because not all, like, think of a DAW, for example. The DAW, if you disconnect the current interface in your DAW, the DAW could probably do that pretty easily, just switch to something else. But what's more, I guess, professional, if let's say you're in a rehearsal or something, the DAW needs to tell you, hey, connect your cable back because you want to get the audio back through that thing. So what might a user code would do is kind of, call you with a callback that it disconnected, but not do it for you. It's not going to fall back on something for you. It's to just say, hey, do you want to, try again every second until the user got it right, and then continued playing audio or something along these lines. So you need to kind of broadcast this information, and I think RT Audio does provide this information. I need to check more thoroughly. It just doesn't provide it in a way of a callback, but we can build this stuff on top of it. Okay, there's another question here. What do I think about Lua scripters? So Lua, I'm not well versed in Lua. Lua is a great scripting languages for a variety of things, specifically for games, right? Lua is very, very different from C++ because if you think about it, in Lua, what you're doing is you're basically triggering events that are happening on the C++ side or some other language. Like your game code would be written in a language like C++ or Rust or, I don't know, C# or something. And then you would trigger a call to Lua to evaluate some logic, and it would return a value back to the C++ code. So it's more of like an interface for for the C++ library. And by the way, a lot of languages are like that, like a language like Python or something. So if you're using Python, the real system code is written in C++, Rust, something in this area, and then you write the Python code to kind of add user logic around that system code. So it's the same with Lua. I think Lua is awesome. I've never used it myself. I've seen streams of people using it to script things for games. I know people love it. It's I don't have like any professional opinion about this because I haven't used it. But I know that in the C++ community, actually a lot of people love it because of the C++ integration that it has. It's very, very nice. It's very easy to kind of build along with your game. So I know people love to use it. It has hot reloads. So you can just change the scripts, midway through their game run and just have a new script. You don't need to rebuild the game to try a new script. So it's so it's a cool language. I don't want to sound like I know too much about the specifics of the syntax or anything. Okay. Let's get some water here. This is my first time streaming for hours today. Like I was streaming for a couple of hours before, and I've been streaming for hours. It's definitely an interesting thing to do. Like just go on a stream and get work done. Okay, so where were we? What was I doing? I completely forgot. I want to add something and I forgot what it was. Lost my train of thought completely. I was doing something with the prepare call. Something like that. Prepare call or process call. What else did they do? Oh yeah, I just remembered. I wanted a way to compare these, not the stream config stuff, but the audio callback info stuff. So what I wanted to do was to have an easy way for the user to know if that has changed from the previous callback. So what I thought I would do. Yeah, that's not a bad idea. So one way to do this is to write like a custom comparison operator. Like C++ lets me define what it means to compare this. So it's going to be something like a bool operator equals with another audio callback info, or with another const ref to callback info. And when I do this, I don't need to compare everything, right? I can just compare return num inputs equals to other num inputs. So the inputs could have changed, right? Or num outputs equals to other num outputs, or sorry, not or, and, right? All of those conditions should prove that it's equal. So num outputs are the same, and sample rate equals to other sample rate, and what else they do? Max block size, other max block size, and I think that should be okay. This is a const method, and for completion I can also do something like bool operator not equals. And we should just return the not of the other one. Just the opposite of the other one. Great. Why did I do this? This is because this should allow me to do something like, I'm going to do something hacky right now. So let's say on the user code, instead of doing this manual comparison, first of all, like I should be able to just store, last info or something, and then I can do if info isn't exactly like the last info, then sample, kind of assume that something changed, and then I can do a bunch of memory allocation. I should probably also save this last info. This is actually going to be should be quite an easy operation, because even though this block has supposedly buffers, it's only holding them by pointers and stuff. So as long as I don't touch this data, I think everything here is just primitives, right? Stream config has optionals. Yeah, but it doesn't matter actually, because stream config is just a pointer, right? So it doesn't matter. So I just have this as a pointer. Everything else is just like simple ints, void star, blah, blah, blah. Yeah, so there's a comment here on YouTube. First of all, thank you for this comment for Refrigerator Verd, for good content. Thank you. Yeah, I'm gonna try doing a lot of these streams. I've been doing this coding thing for quite a number of years now, but this is it's fun to kind of share what I'm doing and do something that's public in terms of like code, not just the products. The Awesome Tool says, "Hey Al, long time no see. I started following you during your Project RNL days. Didn't know you were into coding. So for people who don't know, Project RNL is my band. You should look them up on YouTube. We make progressive rock and crazy covers of pop songs and all kinds of other fun and weird music. And yeah, the coding thing has been going on now for almost 10 years at this point. I'm doing mostly audio stuff like music apps, plugins, and stuff like that. So it's it's a lot of fun. Okay, where was I? Yeah, so first of all, I want to see if my comparison operator is going to work. So just to give you a reference, let's go back to my testing code here. What I was trying to do before is I was trying to, I'm writing this audio driver library, and I was trying to create a device manager and set it up with two different configs, one with each sample rate. So one with 48,000, one with 44,000. And I wanted to see if it's going to be easy for the user, right? The user is basically just this function that makes white noise. If it's going to be easy for that function to switch from one thing to another. And intentionally, I haven't done like the full, like the heavyweight implementation here with threading and stuff like that, but I'm going to start with something simple. So let's see if this works. So I don't know if you hear it, but my other speakers are playing white noise, and you see each time they stopped, right? It says sample rate changed, block size is the same, but the comparison worked. Let's try doing the same thing, but not change the sample rate. Instead, I'm going to change the block size. So I'm going to do student block size or something. I'll use the same sample rate, but I'm going to have a different block size. So I'm going to start with 512, and then I'm going to change it to 256. Let's see if this is going to work. 512, I'm hearing some white noise. Oh, that's interesting. Okay. This is interesting. Okay, so this didn't work. Because it seems like, even though I asked for this block size, this is interesting. This, let's see why. So it looks like something was not passed correctly here. Let's see why. I was doing set config, open stream. And here, let's see. In here, I was. By the way, is my audio fine? Is everything okay? I don't know if you can hear me. Everything is working okay. Let me know in the comments if this is all good and correct. So. I gave it a config. I'm saving the config. So let's see if this was called correctly. So the first, I'm gonna place a breakpoint here. First config, 512. That's good. Second config. Here's the second config. I asked for 256, but it looks like I asked to open the stream. When I asked to open the stream, yeah, that seems fine. That didn't change. That all looks correct. So what happened here? What happened here? Oh yeah, so I get a message. There's cracks and pops. That's interesting. I wonder why that happens. Yeah, maybe it's when I'm debugging something. Yeah, that's interesting. Maybe it's probably because I'm debugging something. Does it stop now, or do you only hear it when I'm hitting debug? That's interesting. I wonder what could cause cracks and pops. That would be annoying. Hmm. Yeah, I have no idea why that happens. That's so weird. I did hear those in the previous stream, and I thought that I tested a few things. It seems correct. I wonder what this could be. It's probably this streaming app that I'm using. Yeah, maybe what I'll do. This is interesting. I'm hoping this is going to work. I'm going to remove. Is going to impact anything? Oh, only when I hit the bug. Yeah, that's interesting. Yeah. It's hmm. Yeah, I know about that. Just looking at my settings here. Yeah, I wonder why that happens, because I'm not even opening this right now. I'm not even debugging through the device that I'm streaming through, but who knows? Oh, you know what? I have an idea. Mm, no, I have no idea. Absolutely no idea. Interesting. Okay, well, let's. I hope it's not going to get too bad. Yeah, this is. It's definitely an interesting situation where I'm trying to stream from the same computer I'm doing audio programming on. I'm guessing things could happen. Oh, you know what? There's something else. I'm going to change something, and hopefully the stream will not. I'm going to try something. Let's hope the stream is not going to die from me doing this. Let's pray. Everyone pray. Okay. Hopefully now I have audio. Okay. So, Abhishek says, I'm pretty sure it's only when you hit the bug. Oh, there's something else. Is there some sort of CPU restriction that prevents more than one real-time audio thread from operating at once? Actually, no. For example, if you look at DAWs, right, like Logic, Reaper, etc., those are running multiple audio threads. You can actually debug that. It will actually be a great thing for a stream, the way this works. Like you can actually open, the Mac activity monitor on Logic, and you will see that it's using multiple real-time threads. So it's not that. I'm hoping that it was the thing that I just fixed by disconnecting things. I've had my whole world go through this hub, which is like a Thunderbolt hub, and I just took apart things and connected them directly. I'm hoping this will fix things. I'm really sorry about the audio problems. So hopefully this is going to sound good. And I want to say hi to Arthena, or Elanda as I know her. She was very, very active and provided amazing details in the previous stream, which was just a couple of hours ago. So let's go back to where I just was. So just to recap, I'm building this audio driver library that currently wraps RT audio. In the future, we'll have some more backends possibly. Like a cross-platform thing. It's gonna run just like RT Audio itself on Windows, Mac, and Linux. In the future, I'll wrap something like Juice as well, and we'll also have iOS and Android. Might have other backends. Yeah. So let's just loading my IDE back. Okay. Let's see if I need to start sharing my screen. Everything restarted here. Good. Okay. So last thing that happened was that I ran into a bug. What I tried to do was that I was trying to, this is my user code here that I was trying to kind of use to demo the library. I was trying to set a different block size. And I noticed that, let me run this. Hopefully this will not, freeze the world. Yeah. So what this should do is this should, in theory, get a config with a block of 512 samples, buffer size, wait for 3 seconds, then change to 256. But as you can see, I did not get a 256 here. So something did not work, and I'm trying to figure out why. So I'm trying to see, maybe I didn't pass this correctly into the call into RT Audio. So what happened was in my call to RT Audio, open stream something. Also, everyone, please let me know if my audio is now fine. Hopefully it's not going to die. Okay, so okay, so it does look like, you see, I request 512, and on the other side of this, I got because the way it works, the stream class refills the address of this. Like I gave them a pointer, I gave them the address of frames, and they should give me back the actual one that was used. Now let's look at the next call here. Wait a few seconds. Next call happened. Let's put this here. I asked for 256, and at least the it looks like the driver is happily answering. Like they say that that I'm getting a 256 back. So that part is fine, but maybe there's some other problem here. Maybe I didn't fill this information correctly in the type that I created. Like it's possible I created some type, like I called it something like audio callback info. And it's possible that I didn't fill this thing correctly, maximum block size. Let's see why. There's a function here. That fills this information. And I filled with number of the actual number of samples, which seemed to make sense, but I guess not work as I was expecting. Let's see why. Number of samples. Yeah, 256. So I did save this, right? Yeah, this seems good. So maybe my problem was just in the user code. Maybe this was a last info equals info. That's weird. What happened there? Yeah, I never got a call to change. So maybe my operator equals forgot something. Oh yeah, there you go. I'm just blind. I didn't see that. I wasn't actually comparing max block size to the other max block size. That's why I didn't get a call. So let's see what happens now. Can remove my breakpoints. I'm waiting 3 seconds and a new block size came in. Great. Okay, so this worked. So I'm going to commit this state because I've changed a bunch of stuff. I'm going to do something like added a way to compare previous and current audio callback info. Nice. So this is the first step of what I wanted to do. Really what I wanted to do, I don't like the idea that this comparison keeps happening because it's kind of pretty low level thing to do. I might want to do something that will help the user do this. So what I could do is I can actually create my own callback, like a library callback. That's also going to give the user a way to get this, just get a callback when something changed instead of doing this. So that this will go away, and instead of this info, and instead of storing the last info and comparing them and all that stuff, I would have the kind of the library do that for me. So Athena asks, what's my commit scheme? Like every feature update. Yeah, pretty much. Like usually when I'm, when the code is more structured, I guess, and there's more sanity to it, I would try to make the commits, be more self-contained, right? Like it's actually possible that what I've done now is if I will actually look at my Git history, it's probably source for like 3 different commits at least. Like if I look at my Git history, like let's look at this last commit. Like I've changed, like, let's see what I probably changed tons of stuff. Like here, I added a way to store the previous sample rate and latency. So I've added a bunch of stuff. I'm storing this last info. I've added, I've changed some variable names. I moved around this function to get the number of channels. I moved it from one place to another. Like I've done like a bunch of crap. Oh, and I've added something to get the interleaved input. So it probably should be like source for like 4 commits or something. But just because I guess I was streaming and I'm like rolling, I'm not as following organized practices in how I commit this. But I'm hoping that it kind of helps to create a more entertaining stream, hopefully. Need to breathe a little bit. Are there any questions here? Anything in the comment section? Just to let everyone know again, I'm streaming this on a few different networks. Like this is streamed on YouTube, Facebook, Twitch, Twitter, X, LinkedIn, something like that. So it's possible that some comments come in from one network, and then I will try to show them on screen and answer as much as I can. I think I should use that more. My commits are usually every few days. Yeah, you definitely want to commit as often as you can. There's quite a few reasons for it. One is backups, right? That's like the simplest way. Like it's really annoying when you screw something up, but you really don't want to roll back 3 days of work, right? You want to only roll back, an hour or something, like something that makes sense. But also, in this project, probably definitely the initial commit history will be a mess because especially the parts I'm doing on stream, but it does help to know what you did. Like I sometimes will look at the log and say, hey, did I do something related to this 2 hours ago? Because I might want to look at this change because maybe I introduced a new bug. I want to go back to where I think maybe the bug was introduced, right? So it definitely helps to commit often, I think. I know what some people do. I'm not an expert in it, but I know some people do it, is that they will squash the commits later. Like they will have a lot of small commits and it's a mess, and then they'll clean it up into like a beautiful organized set of commits. Which I probably should do, but I don't do that. Okay. So what are you going to do? Okay. So what I want to do is I wanted to simplify even more the user code in this space. Basically what I want is I want to create a slightly higher level callback. Let's imagine that this is not the callback, but instead the callback is something that's slightly more stateful and holds the last callback and stuff like that. So here's how I would do this. I'm going to my to here. Right now, this is the callback that I'm providing to RT Audio. Like this is the callback where basically, as I've shown before, I'm grabbing a few things that they provide to me, like the sample rate, latency, and number of samples, the buffers, stuff like that. And then I create this nice structure that I pass back into the user. What I will want to do, I want to actually take another step here, just to help the user get a bit more get set up, I guess. So what I will do is let me think. So one simple way, that the way it's done with a lot of frameworks, is with inheritance. And I'll just show it, but I probably won't go to that route. With some classes, with some frameworks like Juice, whatever, they'll do stuff like processor, right? With virtual destructor, processor. And then they'll have like something like a function that calls process, right? With audio callback info something. And then they would have virtual function, and they would have another function called prepare. I can probably pass the same thing in there. Something like that. And the idea is that I can then supply the user with kind of dedicated callbacks. I don't know if I love that. It's possible that this is I don't know. I don't know if I want to, like, so what that means, that the user would have to inherit from this and give me a processor class, and then I can actually add some stuff around this. Like I can store, like, something like that, previous, and make it private, and then if it's like I can do a bunch of stuff around this thing, And it's simple to write, but I don't know if I love this. I don't know if I love the idea of injecting inheritance to the injecting something like that to the user. I might do something else. So the first thing I could do, Athena says, how about the clap approach, all callbacks? Yeah, I think that would be better to have like straight up callbacks. I think it's going to be slightly more, composable and less restrictive in this case. What I'm trying to think of like, what's the way to make the user code expressive? So one way I thought about doing this is, when I'm looking at the example code, what I don't like here is the statefulness of holding the last callback and then comparing it. Like, I don't like the state management the user has to do. I think it's kind of boring. What I might do instead is I would go here and I would do the state manager for the user. So I would do something like prev info or something. Let's store it here. And when I create the info, I'll probably have to do this thing public. All the public stuff I'm doing here, by the way, are not going to be public to the user. I'm going to hide all these behind an interface, but they will be public to the to this horrible stateless callback that I've had to use. So what I'll do here is that I will so I'll do what I'll do is I will store a fresh something like that, like a changed callback or something. A change what's the word? Change boolean, right? So I'll just go to this thing called info, audio callback info. Which I need to find a shorter name for this because this is under namespace anyway. It's I'll find a better name for this in a second. I'll have a boolean here that says something like changed, should prepare. What would be a good name for this? Yeah, I can do something like changed. Changed, right? Does it make sense? Like I want to have the user see if this changed. Maybe settings changed, config changed, new config, dirty. I think I said dirty. Dirty makes sense. If it's dirty, let's try dirty. Let's see if that works. So I'm gonna put dirty there, and then what I do is in this callback, I'm gonna see something like I'm gonna do the same thing I basically asked the user. I'm gonna do if info isn't the manager. What's it called? Prev info, then manager prev info equals info. And yeah, and it only needs to be true. It only needs to be true for this one. So I need to make sure that otherwise. Yeah, so dirty is only stored in the one that's passed locally. I think that's correct. Like I don't need to store that it's dirty for the next runs. So I think that should be okay. I can also probably do something like else info.dirty equals false. But I think that will be fine, right? It's because that thing only gets tossed away. Yeah, I think that's correct. Who knows? We'll see. So let's go to the example, and the idea is that what this should be allowed to do is remove this and just do if info dirty, do this, and there's no state management, right? So in theory, the user would have something like a prepare call in here, right, where they allocate memory. And then the user has to set it up. I'm not setting up any specific callback type. This is like something the user can do with an if statement. So this would look something, whatever. The user would do this. And here, the user would allocate memory and do stuff like that. Let's have a look. Let's see if this works as it should. Yeah, so that worked. I had now my my audio, which you probably didn't hear, run for 512 samples and then 250 samples. By the way, is my audio fine now? Was that fixed? Were there no cracks and pops, or is it still cracky and poppy? Athena says, I love about C# that you have properties. It's like assigning to a normal variable, but it has callbacks. No need to update a whole struct. Yeah, that's probably true. I mean, the thing that's interesting about this. Okay, so Abhishek says we're good. Audio is good. So I'm glad. So it's probably just me need to not be lazy and connect things to their own port on the computer. That makes a lot of sense. Okay. So the call. So the I guess the part I'm interested in is how to make the user code. This is what I call a user code, right? The user does some process block, some sound, and then if they need to do some prepare or something. Yeah, the advantages about this is that it's kind of clear. Like that's something, for example, with Juice is not so clear. That the prepare call is somewhere in a different place, right? Like you get a virtual prepare call, but you have no idea which thread is going into. Is this actually like I've seen a lot of people that don't know that prepare cannot be called during process. This kind of makes it clear because there's no extra callback flow here. Like I've seen people, for example, in the Juice forum try to do stuff like when they get a virtual prepare and process block, like they're called not from this flow. I've seen people try to put locks, like they'll try to put stuff like a std mutax, something, and then they'll try to lock it, right? Like a lock guard. Lock mutax, something like that. And because they would be afraid that if they allocate memory here and work with some shared memory, they would collide, right? But because prepare gets called directly from process, I think, and I've not looked at all the possible, possible versions of this, but I think the advantage of this is that it kind of hints that the user wrote this prepare call, right? Not the library. So there's no magic. There's no magic that happens here about how this got called. Like it's very obvious that it's before the process block. Which at least again, I've not looked at every possible combination, but I think this is kind of correct. By calling this right here. The main thing, I guess, that is important that I did not look at is I think in theory some of these stuff can also change without the process block running. And I think that's an interesting use case. Okay, so this is let's start with that. This is I think this is a better place to be in. Let's edit a dirty flag whenever a new configuration is applied. Okay, so this is I guess one way to do this, right? This is so user code, I guess, makes a little bit more sense. Now let's talk about something else. Let's see. By the way, any other questions from the chat before I move on to the next topic? I think next topic will be like just serialization. I'm gonna start storing and loading this from a JSON string or something, because I think this is very important. So Arthina asks, so prepare happens on the processing thread. Wouldn't that cause dropouts on changes? Like you could have like a double buffer approach or having on the other thread. So actually, this is how it happens in Juice too. So in Juice, prepare to play almost always happens on the. I mean, I guess prepare could happen on other threads. I guess maybe on Vista. I don't know. I'm pretty sure it almost always happens on the process thread. I think it makes sense because, yes, and by the way, there are dropouts. Like one of the guarantees of all the plugin formats, for example, is that prepare and process are never at the same time. Never. Like there can't be. If prepare and process in Juice would happen at the same time, everything would fail, because in prepare you're allocating memory, right? Now, you could, in theory, just like you mentioned, create some multi-threaded approach. Like, go in a prepare call and then prepare everything, put something in a FIFO and move it to the processor or something. But I think that would make that would create all kinds of complications. To handle such bookkeeping and I think in practice, like if you're in a DAW, like for example, think about like changing the sample rate, right? You change the sample rate in the DAW or the buffer size, audio is going to stop. Like there's no way audio is going to be running smoothly. And I think the device driver is going to stop even if my code will be running smoothly, the device driver is going to stop. Like I think the device is going to stop, reinitialize stuff and call me back. Like I don't think there's a way to have smooth playback on that. Abhishek asks, is this code uploaded somewhere? I would love to see the entirety of it as you're doing the stream. Yeah, I would, once this is a bit more clear, a bit more organized, like, I don't know, a day from now or something, I'm going to post this publicly and start to work like that. I just don't want people to, I don't know, maybe I'm too cautious about it. Like, I don't want people to use this because it's a mess. It's not something that like I don't want people to start to say, hey, I've used your library and it failed when I did this, because this probably fails in multiple places. I haven't tested a bunch of it, but I will make this available on my GitHub tomorrow or whenever I'm comfortable that it's kind of solid and working. Yeah, I mean, the comment is, honestly, just give no warranty, then people are on their own. This is, I guess you could say, here's some code, do whatever you want. Maybe I should do that. Maybe I should just make this public, why shouldn't I make this public? What am I, you know what, let's go right now. I'm just going to go to my GitHub. I'm going to warn, I probably need a README here. There's no README. But let's start with this. There's nothing proprietary about this. So let's do, you can see what I'm doing because I don't want to show you all of my secrets. But I'm just going to go and see, where's this thing? Where do I change this to public? I forgot where it is in the GitHub group. I know you don't see what I'm doing, but it probably should be somewhere, right? Probably should be some setting of the repository, right? Okay. So, I need to confirm that I'm me. Hopefully that's true. Okay, so I made it public. If you go on my GitHub, which is yeah, so if you go to my GitHub now, which is github.com/eyalamirmusic, I'm just going to paste this. This is called Make a Sound. Please don't do any commercial use. Or any, not even commercial. I mean, you can use this commercially or whatever. The license will let you. Please don't put this in a program that's used by other people until this is properly tested and maybe, properly organized. But I just posted the link. It didn't show up everywhere. I know I can't post it on LinkedIn. I don't know why, but it's on Facebook, Twitch, and YouTube. Maybe I can show it on screen. Okay, I can show it on screen. This is the link. And while I'm here, while you can see this, I'll just go over just to give you an idea of how this is used, right? If you definitely want to look at this. There is a CMake file here. I was trying to keep it super simple. So what this does is once you will configure the CMake file, this will just grab RT audio from GitHub automatically. There's a way to inject like a local copy and stuff like that. I'll probably discuss all of these options. But if you have, an IDE that supports CMake, like Visual Studio Code, Visual Studio for Windows, CLion, this should just work. And if you're using something else, like you want to use Xcode or something, you can just do something like, let me open my terminal here. Where's my terminal? Here. So I can do something like, what is this doing? Why is my terminal? Wow, my terminal changed. I have no idea why. That's so weird. I've never seen the terminal like this. I have no idea why this. Let me just load the normal terminal. Here's something like code make a sound. So if you're here, hopefully you can see what I'm doing in my terminal. So you can just do something like CMake -G, Xcode or something, -B build. And this would generate an Xcode project. And it's going to do some, dependency fetching and stuff. Bring RT audio from GitHub. Finished. And then you can go to the build folder. And I just you didn't see what I was doing, but I just went and opened the Xcode file that it generated, and it created this with the example thing, and you can just build it. Built, and it should hopefully play sound. Some of these configurations here will fail on some systems because there's some hand coding or some hard coding thing that happened here for the example app, which will slowly change over time. Like, I'm not sure, you might need to switch to the default config or something for it to make sound on your system. Okay, so Abhishek asks, how long do you think it would take to organize such a system? I'm wondering how massive the problem that you solve is. So first of all, to be perfectly honest, what I'm doing now, for now, I'm not solving what Juice is solving in terms of, even if just we're talking about the Juice audio device manager, because Juice are actually doing a bunch of the low level stuff. Like they have implementation around SEO, they have implementation around core audio. They actually wrote super low level stuff. I'm using a library called RT Audio that also did these low level implementations. So it's not like what I'm doing is like I'm not solving the real difficult problems here. What I'm mostly doing here is I'm trying to create a nice user flow for what RT Audio and other stuff we did. And it's possible that in the future, if this library would get popular, I would do some hand implementation of some of these as well, just because it's possible I would find that the way they implemented SEO or something is not perfect, and there's something I'm not saying that it's not perfect, but maybe it is, and I can build something on top of that. So or build something instead of that. So yeah, so I'm cheating in that sense, right? I'm just doing the user flow. I'm just taking all the horrible details that Juice and RT Audio whatever had to deal with, and I'm giving this to you in 2 lines, right? So you can say it's more of an API thing. It's also possible, by the way, that at least in the RT Audio case, I can probably make this header only, right? Because the RT Audio itself is just one CPP file, and I can probably just have it pre-included so that you can, instead of doing this package management stuff, you can just, hey, include make a sound.h RT Audio, and that's it. Like, this should fix it. The better question is RT Audio the right choice for the job? I mean, I know some people use it. I didn't just randomly pick it. So the reason why I'm working on this way is I was chatting with Julian Storer, and he mentioned that he did similar implementation of this for C major. And he's actually helped me, gave me a few tips, and we discussed a few ways that this could maybe work. And so I know that it's a good library. I know that it's pretty widely used. It's very popular. I'm not saying it's the best. I'm just, it's very possible that in the future I would, not just in the future, pretty soon I would abstract RT Audio away, and the interface itself would be supporting multiple backends. Where probably the first backend I'll do after this will be Juice Audio Device Manager. So if you have, it's not going to depend on Juice, but if you have a Juice license, you could just say, well, just give me the Juice backend without changing the user code. So it's very likely that this is something that I would do. And then maybe in the future, maybe I would write, for example, a custom iOS implementation that I would just do against the system drivers. Like I don't want to limit this to a specific backend. Like I'm just going with RT Audio because it's free, it's open source, it does Mac, Linux, and Windows, and it's it's relatively simple to set up and connect to your thing compared to the Mac native libraries or something. Athena asks, if we ever get Studio Audio, would you consider that instead of RT Audio? Yeah, for sure. I would definitely make a backend with Studio Audio if that's an option. Like, why not? That would be a great question, by the way. Like, would Stud Audio answer everything that I'm doing here in terms of API? I don't know. Maybe, right? Like, if Studio is a proposal, by the way, for the C++ standard, and I think if this is added, then there's a really good chance that I mean, it's like for example, let's say you use my library, make a sound, and you call something, like there's going to be a backend that just, if you did this, then Studio Audio did this, and kind of just routes all the calls, and everything I'm doing on the stream will seem very boring at that point. But that's future looking. Wow. Okay. The comment is they have the proposal somewhere. It lists some nice features alongside Stud graphics and UI stuff. Yeah, I'm definitely interested. I've been in ADC where they presented it, I think, for the first time. It looked really interesting. Yeah, but also, once it happens, until it gets actually implemented in compilers. So we're talking about, it's not going to come in C++ 26, right? We're talking about C++, 29, 30 something in the future at the minimum, and then an implementation in 32. So we're talking about like some 8 years down the road until this is like, in professional software. So so I think even if in 2032 we were going to get rid of of Make a Sound, I think it's going to be worth it, hopefully. All right. All right, so hopefully that was cool. I need to take a break. I don't know, maybe sleep or something at some point. So I know it's possible I'll start another stream later if I'll have more energy, but it's also possible that I'll fall asleep and I'll continue this tomorrow. Thank you, everyone. Hope you enjoy this repository. And yeah, I'll come back very soon.